Hello my dear champions, welcome back to our channel Deeksha Karnataka. Today I'm here to deliver the third class in the mathematics of the series Masterstroke. Today the chapter will be matrices, so not very complicated chapters, but the concepts over here are very important because easy and high scoring as well, and the application of this chapter plays a big role in determinant, right? So matrix and determinant has good amount of weightage in your KCET and boards, so you have to pay complete attention in this class. And in the previous live we all saw that many of you were asking that are we starting today, so if you are starting today can we get the good marks in our KCET? Yes, you can if you follow our Masterstroke series properly. When I say properly, what it means is you have to watch the entire class, you have to download the class notes. How can you do that? The class notes will be provided in the WhatsApp community. You got to join it by clicking the link given in the video's description. Go ahead, check the link out and join the community, get the PDFs and revise the entire concept which is given after watching this particular class. Okay, now alongside that I keep coming after clubbing 1-2 chapters together, keep coming for the live where I discuss more and more questions over there. So you have to join that class also and learn the questions based upon these concepts once again. Okay, so I think we are ready to start the class now. So with this, let's begin. And before I start the session, I want to tell you all, I want to know in the comments how many of you have already taken the ABHYAS KCET test series. I think many have already taken that. We have quite a good amount of enrollment in the ABHYAS KCET. But if you are not ready, or if not taken right now, do one thing. Take the free test that is available for you. It's for your benefit only, I'm telling you, because KCET is getting very near. You don't have much time right now, and you have to solve 31 paid plus 4 free, which means 35 mock tests you have to solve, and you need time to do that. And the time is running day by day. You have to start solving the papers as soon as possible. You need to work on accuracy, work on speed, and all of that can be achieved by solving many and many KCET related mocks, and that is ABHYAS, available at a price of 1499. And if you can see here, recommended by your seniors who gave KCET last year and got outstanding result. Prajwal at 171, Kiran at 443, Deeksha 693, and Sachin Sastri 934, Mohammed Sahil at 2427, and many more results we can't even show in one slide right now. Okay, so the subject will be offered here is PCMB, and you'll get chapter wise KCET PYQs for last 10 years, and all will be as per the KCET exam pattern and timing. It'll be an online mode. I hope you know that this is an online test series. This is not an offline test series. This is an online test series. You can access from anywhere once you take the course at a price of 1499. The link again for the ABHYAS is also given in the video's description. Please check this out. Now, what is a matrix? What is a matrix? It's a rectangular eraser. We saw in the title slide also. It is a rectangular eraser where we store data. Yes. Okay, so you know that, right? In the actual world of science and mathematics, the data that we have is observed, and it's not very easy to control and add, subtract like that. Okay, so what we do is we store this data in rectangular arrays, and that is called as matrix. Okay, so which will have what? Which will have features like, of course, these horizontal lines where you add data is called as, these are called as rows, and the vertical ones of course are called as column. These are called as columns. Okay, these are called as columns. Okay, so if the number of row and number of columns are not equal, we usually write this number of rows as m and number of columns as n. This is the usual representation. You can write any variable over here, but m cross n represents, m represents for the rows, the number of rows, and n represents the number of columns. Okay, number of columns. So this, if m and n value are not equal, if m is not equal to n, this type of matrix is called as rectangular matrix. It's called as rectangular matrix. Means either of the side will be bigger in size, right? And what about if I have m equals to n? Then this type of matrix is called as square matrix. It's called as a square matrix. And I hope you've all heard about determinant. Determinant are solved only for this particular case of square matrix. You cannot find determinant of a rectangular matrix. Okay, so what is a matrix? It is a rectangular array where we arrange or put datas inside. It can be variable, it can be a constant, it can be real number, imaginary number, can be anything. Even a function can be put in the places of as the element of the matrix. This is called as element. If I have A11, A12, A13, A14, okay, same way A21 and so on till A44, till A44. Where you see over here carefully, this A11, what it means is, this means first row, and this means first column. So basically, if you know the element is present in the first row and first column, of course it has to be the first element. So the A11 actually is the address of any given element. It's written generally as like this: A I J. What is this? Address or location of any particular element. Means how will you locate an element? Depending upon the ij values. What is the I and j value? I represents your, what is it? Row, and j represents your column. You will see which row and which column this is contained in. For example, if I write here A22, it means that this element is in second row, second column. So this is the second row, second column. So you get the position identification easily done over there. Have a look. So these are the basic information about what a matrix is, what are the elements of a matrix, how can we write it them, okay, difference between the rectangular and square matrix, and so on, how to write an order. So this value you see here is called as order of a matrix, again. So the order will be defined like m cross n. Now it will be defined for both rectangular or square. Okay, even square matrix will have an order, rectangular matrix will also have an order. Okay, because if there is a row or column involved, of course it will have a order over there, sir. Moving on. Now definition part, this much is clear, sir. Definitions now. So as what I said right now, mentioned over here, matrix is an ordered rectangular array of numbers or functions in horizontal and vertical lines called as rows and column. You write them by enclosing them in a square or a small brackets, generally denoted by the letters capital A, capital B, capital C. Basically this matrix will be written as matrix A equal to this. Okay, element of a matrix is what? The number or the function occurring at different spaces in the matrix is called as, which is arranged, is called as basically your elements of a matrix. Order also I explained you, elements also I explained you. So first slide is already been taken care of. Moving on. Types of matrices. Some definitions are there, not that they're going to be very useful in all the questions. So of course that question over here doesn't come that much. For example, on row, column, we don't get definitions of the questions, like questions on the definitions, but we do have applications of all these learnings. Let's quickly go through them. Row matrix means that this will have only one row like this. This is called as, let's say 1, 5, 9 and so on. It can have any amount of row, no, not column. This is example of column matrix. I said row matrix, excuse me. Row means you'll have only one row, so 1, 5, 9. It can have any number of columns, but row will be only one. This is called as a row matrix. Okay, what is a column matrix? Again, same thing. It means you'll have a column like this, one column containing only one row and only one column is called as row and column matrix. Null matrix means where the element value is all 0, okay, whose each element is 0 is called as not 1, all the elements should be 0 is called as null matrix. It can be 2 cross 2 order, 3 cross 3 order, anything. A square matrix, as I mentioned, whenever this value m and n means number of row and number of columns are same, they'll be called as square matrix. So very simple definitions are there. Elements, how we write it, as I mentioned, A11, A22, A33, okay, all the way till A and n. Ij represents the row and column base, okay, and when I and j are not equal, they are called as non-diagonal elements. What it means is, if I write an, let's say 3 cross 3 order matrix, 3 cross 3 order matrix, if I write A11, A12, A13, A21, A22, A23, A31, A32 and A33. Check here, these are called as my diagonal of matrix or diagonal element. This is called as diagonal of matrix where the I and j values are equal. I and j values are equal. Okay, so if I and j value is not equal, is called as non-diagonal elements, means other elements a1, 2, a1, 3 and so on. Okay, so this element where the I and j becomes equal is called as diagonal elements or diagonal of the matrix. Okay, what is the meaning of diagonal matrix? When the non-diagonal elements are 0. When the non-diagonal elements are 0, check here, non-diagonal elements is 0 are called as diagonal matrix. Example, sir, I can take a 2 cross 2 order matrix. Let's write here 5 and 9, 0, 0. This is a diagonal matrix because diagonals is 5 and 9 and other elements are 0. Next, scalar matrix. Scalar matrix means, again, these are all same. Means if I write here scalar matrix, I write like this. Example, 1, 1, sorry, let's write this 4, 4, 0, 0. This will be a scalar matrix. What about this, sir? What is the unit matrix? It's the same as scalar, but there's a difference. It will be always 1, 1. So yes, every unit matrix is a scalar matrix, but not vice versa. Every unit matrix is a scalar matrix, but not vice versa. Only when the elements are 1, 1 in diagonal, then only we call that matrix to be unit matrix, or also called as sometime identity matrix. Also called as identity matrix and given by IN. N represents order. I hope you understand these properties are true. What properties? Diagonal matrix or scalar matrix or unit matrix are true only for square matrices. For a square matrix. You talk with respect to diagonal only in the case of square matrix. So scalar matrix is what? Example I can see 3, 3, 3, 0, 0, 0, 0, 0, 0. So all the non-diagonal element is 0 and diagonal elements are all same, is called as scalar matrix. If I want to write unit matrix, I have to write like this 1, 1, 1, rest all 0. Rest all 0. Clear? Good. Lower triangular matrix. Lower triangular matrix. A square matrix in which each of its elements above the diagonals is called as 0 actually. Example over here. Let's say diagonal over here. Let's say 5, 9, 3. Here these elements are 0. This is called as, so above the diagonal elements. This is my diagonal element. So anything above that is 0 is called as lower triangular matrix. Just opposite will be what? Upper triangular, means you'll have these elements 0. So lower, after below the diagonal, if the elements are 0, is called as upper triangular matrix. Okay, what it says, when I is less than j, check out here, what is the value of this? A12, what is the I value? I value is 1, sir, and j value is 2, sir. Check this element, A23, I value is 2, sir, and j value is 3, sir. Is I less than j or not in all these cases? Yes, sir, I is less than j. For all values where I is less than j and the elements are 0 is called as lower triangular matrix. And over here, what is this? A31. What is this? A21. What is this? A32. And for all these elements we have I value more than j. When I value more than j, and for those elements, if the elements are actually 0, then what happens? That is called as upper triangular matrix. Comparable matrix. Now from here onwards your question solving starts. Comparable matrix means what you can compare, when you can compare the two matrices. Let's say if I have matrix A and matrix B. When can I compare them? When they have the same order. Means comparison means what? You check whether they are equal or not, which is bigger, which is smaller, and all of that. So when you can compare when they have the same order. What it means is, if the first order is, let's say, 2 cross 3, this also has the order 2 cross 3, then only you can say comparable or conformable matrix. It's also called as conformable matrix. Next, equal matrices. This is, so not only the order is same, of course, order is same, Is it enough? No. Corresponding element have to be also same. Corresponding elements, elements also are equal or same. Means not only the order is same but also the corresponding element. Example, sir, 159 equal means not only the order is same, also the corresponding element has to be same. So if let's say I had x over here and I say that given matrix are conformable or equal, I'll say x equals to 1. Rectangular matrix, of course, when m and n are not equal. Now question, the number of 3 cross 3 matrix with the elements minus with the entries minus 1 or 1. 3 cross 3 entries, check here. So we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have these many entries. Okay, each will have how many options? It can go to -1 or can go to +1, because entries are -1 and +1, right? Means each of these elements can choose, each of the spaces can choose either -1 or +1. Okay, it means 2 options for this one, 2 options for this one, 2 options for this one, and likewise 2 options for all the 9 elements. So 2 into 2 into 2, 9 times. 2 power 9 is the answer. What is this? 2 options for this, 2 options for this, 2 options for this, and so on 9 times. Hence the answer is 2 power 9. Clear? Next. Now, they're saying that the given matrix is equal. Okay. Of course, order is same. We said that even the corresponding element has to be same. So x plus y will be equal to 0. Let's start from here. X minus y will be equal to 0. Even x plus y is 0. Add them. Cancel. 2x is 0. Basically, x is 0 and y is 0. X is 0, y is 0. What about z, sir? X plus z, last one is 1. Over here you check. So z has to be 1. So 0, 0, 1. Option is A. Matrices are comparable, matrices are equal only when they have the same order, and equal when they have the same corresponding element also. Okay, now we are going to move on to the operations of matrices. First few slides were only on definition, understanding the type of matrices, that's all. Operation on matrices, we have 3 major operations. What are those? Addition, subtraction, and scalar multiplication. For the first 2, we should have the conformable matrix. Means, what it means in simple words, same order. You cannot add 2 matrices of the same, of different orders. For example, if I have 1, 2, 3, 4, and here I have 1, 5, 9, 0, 0, 2. Can you add them? Can you add them? Not applicable, not possible, sir. Does not exist. You cannot add 2 cross 2 to 2 cross 3 order matrix. You cannot do that. So to add or subtract, you have to have a conformable matrix. You have to have the same order. Okay. What about multiplication? This you can do, right, with any order. It means multiplying a scalar like 1, 5, root 5, anything scalar value or k to any given matrix. So 1, 5, k into a, 1 into a, 5 into a, root 5 into a. So scalar can be multiplied in any way, so that's not a problem. But for addition subtraction, it has to be conformable, it has to be of same order. Addition, of course, statement, let's look for the statement. Defined only when the same order is true. Okay, and how do you do that? Add the corresponding elements. Adding their corresponding element. These are the important keywords in addition. That's it. 2 matrices which can be added are conformable in nature, and adding of A and B are not defined when A and B are not of the same order. That's the main thing. Okay. Same. Subtraction. This is same as addition. This is same as addition. I know you all know that, but I'm revising the entire chapter. Okay, that's why I'm not missing out on any things. Okay, I know you all know this very well. Okay, how to subtract? Very simple, sir. Corresponding element 1569 minus 2012. Can you subtract it? Of course, sir. 1 minus 2 is minus 1, 5 minus 0 is 5, 6 minus 1 is 5, and 9 minus 2 is 7. If this is my matrix A, this is my matrix B, this is my matrix C. C is what? A minus B. Clear? Have a look. Properties of matrix addition. Let's look at some properties. So matrix addition is, of course, commutative in nature. Always commutative in nature. Means you can add A to B or B to A. Result does not change. Okay. So they are always commutative in nature. What about associative? Also true. So matrix addition is also associative in nature. So it means you have three matrices, you can add A plus B first, then add C to it, or add B plus C first, then add A to it. You might be thinking, this is so easy, sir. I know it is easy. If I tell you this comes for 5 marks, will you believe me? In PU boards. Yes, look at the PYQs. They have given matrix addition of 5 marker. Have they not? Yes, they have. Okay, so important. So they asked, 2 of them are favorite questions for them. One is associative law, other is the distributive law. Third one, existence of additive identity, means what can you add to matrix A to get back to A itself. That is called as null matrix or zero matrix. Again of the same order. 3 cross 3, 2 cross 2, whatever it is, done. Next, property number 4, existence of additive inverse, means what can you add to the matrix to make it 0? Of course, what is that going to be? Minus A. A plus minus A is what? Simply 0 or null matrix. Property number 5, cancellation law holds good for addition of matrix, means you can add, if you have A plus B, A plus C, no, you can do the left cancellation of A and A, you'll get B plus C over here. If you have B plus A and C plus A, you can do right cancellation for A and A and you get B equal to C. So you have right and left cancellation law valid over here. Property number 5. Scalar multiplication. Okay. Let A be any M cross N matrix and K is any scalar. Sir, you're talking about distributive law. Why did you teach it? That will come in matrix multiplication. I have taken only 3 operations right now: addition, subtraction, and scalar multiplication. That is a different topic altogether. Matrix multiplication to another matrix. Okay, that will come later. Don't worry. That also is there. Can be asked for 5 marker. Scalar multiplication. You take any scalar K, multiply it to A. It means, for example, if I am multiplying 2 with, let's say, 1569, what is my answer going to be? 2 into 1 is 2, 2 into 5 is 10, 2 into 6 is 12, and 18. When you multiply 2 to a matrix, you have to multiply to each and every element of the matrix. That's called as scalar multiplication. Clear? Next, properties of scalar multiplication. So when you multiply a constant scalar to some of the matrix, multiply individually and then add, results remain unchanged. If you multiply with a minus sign, you can multiply and then add a minus sign. Order does not change. You can write it anyway. Property number 2. Property number 2 means if you have 2 scalars, lambda and mu, that you want to multiply to A, you can multiply with A first individually and then add, results remain same. Or this is also lambda only. Lambda mu A is same as lambda mu A, means taken mu A together, or lambda mu together and the last A, or also what is it, mu last and lambda A. You can take in any way. Scalar multiplication, no problem. So far, no problem. When you go to matrix multiplication, then the life changes. When you move on to the matrix multiplication, then the whole thing changes. Find the matrix A and B if this is given. Equations of matrix is given. I'm going to find A and B. Check here, this is 2B and minus 2AB. Add them. 2A plus A, 3A. 2B minus 2B, 0. Can you add these? Yes, they're the same order. 1 plus 3 is 4, minus 2, 4 again, plus 1 again, 6 and 1. So A will be what? 4 by 3, minus 2 by 3, 4 by 3 and 1 by 3. 6 by 3 is 2, and 1 by 3. How do you find, sir, matrix B? How do you find matrix B? Of course, like this, A minus this one, 3 0 1 minus 1 6 2 equals to 2B, right? And then simply move 2 on this side. So right here, 1 by 2 times of the matrix A. Check here. The matrix A is, sir, matrix A is 4 by 3 minus 2 by 3, 4 by 3, 1 by 3, 2, 1 by 3. This is matrix A minus the matrix B, 3 0 1 minus 1 6 2. I am not solving it. You have to solve and let me know. Yes, difference if to take 4 by 3 minus 1 by 3 is how much? It will become 9 by 3 over there. So minus 5 by 3, same, it will become minus 2 by 3, it will be what? 4 by 3 minus 1 is 1 by 3, 1 by 3 minus of 1 become again 4 by 3 and so on. Difference you take, divide by 2, that's your answer for the matrix B. This is the matrix B, matrix A. Simple. Next. Then given A is this, K is that, then find the value of KAB. Can you do that? Of course, check here. A equals to KA. Sorry. We have Ka. What it means? 0, 2K, 3K minus 4K. And this is given as equal to, check here, 3A, 2B, 24. We have only one constant which can be compared, these two. So from here you get minus 4K is 24. So K value is minus 6. K is minus 6. So 2 into minus 6 will be equal to what? 3 into A. 3 2 ja 6. A value is minus 4. Same fashion, 3K 2B. 3 into minus 6 will be equal to 2B. 2 3 ja 6. So B is minus 9. Minus 4, minus 6, minus 4, minus 9 is option B. This was given, right? Yeah. Got it? Yes, moving on. Next question. Simplify this. Okay, multiply now. Cos into cos, scalar multiplication. So cos square theta, cos theta, sin theta, minus cos theta, sin theta, cos square theta, plus sin square theta, sin cos, sin into cos again, sin into sin is sin square theta. Add them. Cos square plus sin square. First one is 1. Cos theta sin theta and then the minus sign of the same thing. 0. Minus and plus again 0, 1. This is what your identity matrix 1 0 0 1. Simple question. Done? Okay. Yes. If 1 omega square are the cube roots of unity, what it means? It means that if you have x minus 1 equal to 0, x cube minus 1 equal to 0, what do you get? You get here x equals to cube root of 1. You get the answer of this as only 1 usually, but actually the other two roots are complex in nature. So you get here the other roots as omega and omega square. So if you solve this now, you'll get the sum of the roots as 1 plus omega square as 0. This is the result of cube root of unity. Okay, check here, there's no b term over here, there's no bx square. So when you add the roots, you get what? Minus b by a. The b is 0 over here, that's why this whole thing is 0. Okay, so this is the other two roots. If you want, you can find it. So omega square are actually the other two complex roots. Okay, now what are they saying in this question? They're saying that, what do we have, sir, here? To find this value, a will get from these elements and b will get from these elements. So I get minus b plus 2 equal to 1. It means b equals to 1. Am I right? B goes there, 2 minus 1, b equals to 1. What about this? 1 plus omega plus a is 0. It means I get, yeah, it means what? I get a equals to basically minus 1 plus omega. I'm looking for a square. So I'll get what over here? 1 plus omega the whole square, and over there I'll get what? If I take b square, it'll be 1. Check, add them. A square plus b square, I get 1 plus omega square plus 2 omega plus 1. 1 plus omega square plus omega plus 1. Separate the 2 omega terms like this. This value is what? 0, 0 plus omega plus 1. Answer is omega plus 1. Now there is another way to solve this question that involves omega cube. Okay, what is that? If you check here, if you compare these two from here, compare these two, you get the a value as omega square. Then you're gonna get a square value as omega power 4. You'll have a square as omega into omega power 3, and actually omega into omega 3 is what? 1. Omega cube is given as 1. Omega to the power 3n is always equal to 1. This is the result. Okay, so when you take n as 1, omega cube becomes 1. So what is this going to be? Check here. This a square comes as omega. You want to add b square to that? What is the b square? Check here, b square is 1. Add them, 1 plus omega. Same thing I got. You want to use any method? Your choice. For this method number 2, you have to use omega power 3n is 1. That's the technique. Omega power 3n, this is 3 guys, 3n is 1. That's the technique. Okay, omega power 3n is 1. Clear? Okay. Next, multiplication of matrices, the major concept from where many questions comes, huge application in everything, determinant also, everywhere. This is very, very important. What is that? Multiplying two matrix which can be multiplied. The question is right. Yes, we want to multiply two matrix, but our question is, can you multiply them? For example, if I have matrix A, matrix B, 2 cross 3 order and 2 cross 3 order, can you multiply them? AB does not exist. You cannot multiply these two matrices. Yes, both of these are the same order. Can you multiply them? No, because to multiply two given matrix, the condition is very simple. Condition is very simple. This value should be equal to this value. They have to be what? Equal in nature. Are they equal? No. It means does not exist. Equal means what? Basically, number of columns in the first matrix. Number of columns in A is equal to number of columns in B. When that happens, only if you can say the matrix product is possible. Only if the number of columns in the first matrix becomes equal to or is equal to the number of rows in the second matrix, then AB becomes completely possible or ready for the product. Okay, and when you multiply, so this is the order condition. Yeah, clear? Any order is okay, but it has to be what? This condition should be fulfilled. Clear? Now, row to column. Yes. So whenever you're multiplying a matrix, you always multiply from where to where? I'll show you. Let's see, this is what? This is 5, 2, 6, 1, 1, and we have here matrix 2, 2, 6, 2. What is this? This is, sir, 3 cross 2, and this is, sir, 2 cross 2. So when you're multiplying this, you'll multiply first row to the first column. You'll get first element. First row to second column, you'll get second element. Now when you go over here, check this out. When you go over here, second row, the first column, you'll get again this element, and then you'll get again this element for the, when you go for the second second column, and the last one, check here, when you go with this, you'll get again these two last. Getting it? So when you have to multiply two matrices, you also go from row to column. Always go from row to column. Square matrix A is said to be idempotent. Always called as idempotent if you have A square equal to A. When square becomes itself, it called as idempotent matrix. Idempotent matrix. Next example. A. What is the order of this? 1 cross 3. Order of this 3 cross 1. Can you multiply them? Yes. 3 and 3 equal. We can multiply and the answer is coming as 1 in this case. So AB is possible. What about BA? BA you check. What is BA going to be? B is, sir, 3 cross 1 and A is, sir, 1 cross 3. Can you multiply them? Equal, so possible. Let's try to multiply these. What do you have B as? 5 minus 4 minus 2. And what do you have A as? 1, 3 and minus 4. And how do you multiply? How do you multiply? So after multiplication, this first one will become number of rows and this one will become number of columns. So it will be a 3 cross 3 matrix. So condition is when you multiply, you get this 1 cross 1. It should be always equal. So they are equal in this case. And the rows over here will become number of rows in the resulting matrix. And the column over here will become number of column in the resulting matrix. Check here. 5 into 1 is 5. 5, as I said, row to column. 5 into 3 is 15. 5 into, excuse me, row to column, no? Yeah, correct. Minus 4 is minus 20. Now second one, minus 4 into 1 minus 4, minus 4 into 3 is minus 12, minus 4 into 4 is plus 16, minus 2 into 1 is minus 2, minus 6 and plus 8 and plus 8. This is my resulting matrix of BA. AB was up there and this is my BA. I think by now you are clear with how to multiply the given two matrices. Clear? Now starts your properties of multiplication. First one, matrix multiplication is not commutative in nature. Yes, AB and BA are not always equal. AB is not always equal to BA. It's equal only when they are, remember, inverse of each other. So AB equal to BA is true if you remember in this case. AB equal to BA is true if it is equal to result as identity matrix, which is the condition for inverse. Remember? Yes. Alright, sir. So not always commutative in nature. First property is dealt with naked. Next. Matrix multiplication is associative, that is you can multiply, yeah, this also has been asked. AB first, then C later, or BC first, then A later. This question is asked for 5 marks. This and the next one, the most favorite one, the distributive property over addition. Multiplication distribution over matrix addition. So you have A times of B plus C, which is AB plus AC, or A plus B times of C is AC plus BC. This also has been asked for 5 marks. One of the most popular property, very commonly, so means chances of this coming is 70% and this is going to be 20%. Other is what? 10%. Okay, that's it. This is the highly likely chances of coming in your 5 mark category of course your PU2 boards. Next, property number 4, product of two matrices can be a null matrix. Yes, even though individually matrix A is not equal to 0 or null matrix, matrix B is not equal to 0, but AB can be equal to 0. How come, sir? Because when you multiply matrices, you multiply and add the elements. When you do that, some can make things different, make this equal to 0, right? If you add 1 minus 1, what is that? 0. Property number 5. If you multiply, if A is a given for a matrix, then I will be a identity matrix, provided that A into I and I into A is equal to A. What is I? Identity matrix. Property 6. A is a given square matrix, 0 is a null matrix. If you have A into 0 and 0 into A is always equal to null matrix 0. Positive integral powers of square matrix. Over here again question comes. Means they ask you power of A power 6, A power 8, A power 2000. They ask that. Those are pattern questions, but all these starts from only over here. Maximum it goes to over here. Any power question is given, we can solve using A square and A cube maximum. We don't have to go beyond that. Okay, I'll show you. Don't worry, I'll show you. So what is the condition over here? Nothing, just use the rules of exponent. rules of indices or exponents. Indices, if you call them exponent, then use that. Exponents. Okay, your choice. Rules of exponents or indices. This is not visible. Yeah. Means when the same base power is added, power rule, all of that is true. Means whatever the rules of indices you have learned, same thing you're going to use it over here. Question on product. Yeah. They're asking the order of the single matrix from here. Let's say this is matrix A, matrix A, this is B, and this is C. They're asking you what is the order of C times of A minus B. Let's say this is the resulting matrix X. What is the order of the matrix X? For A and B, of course, for difference, same order will be there. So order of A is same as what? 2 cross 3, which is same as B also. Same as B also. 2 cross 3. So A and B, in this case, I hope you know that if they're the same thing, it means A minus B also will have the same order, 2 cross 3. Agreed, sir. What if multiplied with C? What is the order of C? This whole thing, check here. C is 3 cross 2. 3 rows, 2 column. Then 2 and 2 is clubbed together, possible. So C A minus B, which is nothing but X, will have the order. Please check. The number of rows is 3 and the number of columns comes from here also 3. Answer is a 3 cross 3 matrix, which is option D. Option D. Clear? Done? Next. A is a 2 cross 2 matrix, B is a 2 cross 2 matrix. Find the value of alpha for which A square is equals to B. Let's find A square first. A square. Multiply these. Alpha 0, 1, 1. Alpha 0, 1, 1. Alpha into alpha is alpha square. 0 into 1 is 0. Means alpha square, the first element. Alpha into 0 is gone. 0 into 1 is gone. So 0. Check here. 1 into alpha is alpha. 1 into 1 is 1. It means alpha plus 1. 1 into 0 is 0. 1 into 1 is again 1. So this is the element. This is my alpha square. What is B value? Compare. 1, 0, 5, 1. Alpha square is 1. Means alpha value is plus minus 1. Two values are there. And if you compare these two, you get alpha plus 1 as 5. Alpha is 4. Sir, answer is ABC. No. Answer is only one correct, right? D. There is no real value. For one value, you cannot have 3 answers, right? Alpha has no intersection actually. So answer is only what? D. None of the real values. Now, next concept and the most important concept for your boards and KCET is symmetric and skew-symmetric matrix, which comes from where? Transpose of a matrix. When I said important, I didn't mean it's difficult also. It's important but not difficult. Let's have a look. Matrix obtained from a given matrix A by interchanging its row and column. What it means is, example, 1, 5, 3, 12, 6, 0, 5, 8, 3. 5, 8, 3. Okay. So except for the diagonal element, right, like this, 1, 6 and 3. Except for the diagonal element, switch the sides of or take the mirror image of the first element. 5 comes over here, 3 comes from here to here, 0 comes from here to here, and the 12 goes over here. So 12, 3, this 5 comes now over here, so 5, and 8 comes here. This is called as transpose of this. Transpose becomes this. Simply switch the row and column. If you want, you can check here. This was the row 153, it became the column 153. 1260 was a row, 1260 is a column now. 583 is a row, 583 is a column now. So to change the row and column in a square matrix, it becomes a transpose of a matrix. It is not true for non-square, basically rectangular matrix. This concept is only true for a square matrix. Clear? This is A, 2 cross 3, then A dash becomes 3 cross 2. Sorry, it can be true, okay, of course. the row and column, this transformation is not possible. This is not possible for rectangular matrix. Transpose is possible for rectangular matrix also in that order, but the row and column will reverse. I was thinking for adjoint part. Okay, so this will be later introduced in case of adjoint. When you go in the case of adjoint in determinant, then that will be possible only for square matrix. Okay, because of course inverse exists only for, or determinant is only there for a square matrix. Transpose will exist for both. Sorry, I messed up with this particular concept of adjoint in my mind. I was thinking about that. Okay, so this is true for both rectangular, because what happens over here is talks about your interchanging of row and column. Just that this order will change, 2 cross 3 to 3 cross 2. In this order will change? Of course not. Okay, both of these are 3 cross 3. 2 cross 3 becomes 3 cross 2 because the number of rows have become number of columns, and the number of columns have become the number of rows. A very simple concept, very simple concept. Properties of transpose of a matrix. Let's have a look. We're about to close this session very soon. Few more concepts are there and a question. Property number 1. Let A and B be any suitable matrices, then A plus B transpose is what? Simply means when you are taking transpose of a sum of matrix, you can take individually and add them, results remain same. If you take transpose over transpose, answer becomes the original matrix itself. Number 3, if you have the difference, it acts the same way you added in the, you had in the case of addition. So difference of two matrix, then you take transpose, or take the difference of the matrices first and then you take, take the matrix transpose first, then you take the difference, results remain same. Means the transpose distributes over the difference easily without any change. Property 4. If you have, this is called as reversal law. This is called as reversal law. If you have 2, 3, any amount of matrix multiplied. So if you have ABC, it becomes CBA if you take transpose. If you have AB, it becomes BA if you take transpose. Got it? So when you take the product of matrices and apply transpose on the product of these matrices, the reversal law acts over there. ABC transpose becomes C dash B dash A dash. Symmetric and skew symmetric matrix. Very simple. Let's take an example to understand this. If you have matrix A, 2, 4, 6, 8. 2, 4, 6, 8. A dash means what? This 2 will be as it is, A will be as it is, 4 comes here, 6 goes there. Okay, add this. A plus A dash. A plus A dash. Check here. 2 plus 2 is 4, 6 plus 4 is 10, 4 plus 6 is 10, and 8 plus 8 is 16. Are they symmetric? Yes, sir. Above the diagonal, these two are mirror image. These two are mirror image. And yes, this concept is actually true for your only square matrix for sure. Okay, previous one was transpose you can find for any of the type of matrix, but symmetric and skew symmetric is true only for square matrices. Okay, color. Okay, so A plus A dash, you can check here. You can see that the elements other than diagonal elements will be what? Mirror image to each other about, of course, the diagonal itself. That's why it is called as symmetric matrix. Symmetric matrix. What about skew symmetric, sir? Very simple. Find this value, A minus A dash. Check here. 2 minus 2, 0. 8 minus 8, 0. 4 minus 6, minus 2. And 6 minus 4 is 2. The result is very simple here. Here Aij becomes equals to Aji. Aji, and over here Aij becomes equals to minus of Aji. Aji. Okay, Aji. Or if I take a matrix X and take the transpose, answer becomes X only. Definition of symmetric matrix. Symmetric matrix. In this case, if you take X transpose, you get the result as minus X. Definition of skew symmetric matrix. Skew symmetric matrix. Clear? So I have A in this way. A dash I found. A plus A dash is my symmetric part, and this over here is my skew symmetric part. It's called as skew symmetric matrix. Now, any square matrix can be expressed in the form of sum of skew and symmetric matrix. Means I can add this, I can write this, one second guys. This is again a question for your boards. Matrix A can be written as sum of symmetric part and skew symmetric part. How do you write that? Simply, this part is called as half of A plus A dash. Let's find this. Check here. Half of this part, 4 by 2, 5, 10 by 2, 5 and 8. And half of skew symmetric part will be like this. Half of A minus A dash. Check here. This is the 0, 0 only, and we get the other two as minus 1 and 1. If you add them together, what is the sum coming as? Let's check. 2 plus 0 is 2. If you add these two, we'll get this value as 2 plus 0 is 2, 5 minus 1 is 4, 4 plus 1, 5 plus 1 is 6, and 8 plus 0 is 8. Check carefully, this is your matrix A. 2, 4, 6, 8. 2, 4, 6, 8. So you can express any matrix in the form of sum of symmetric and skew symmetric by adding half of A plus A dash. This means half of A plus A dash plus half of A minus A dash. Half of A minus A dash. Not clear? One second. Yeah. Half of A minus A dash. This is how you represent any matrix A. Clear? So everything in the skew symmetric and symmetric part is clear. Have a look one more time before we move forward. Next, a question on positive integral power of a matrix. A16 we're looking to find out. Okay. So first of all is to find the A square value. How do you do that? 0, 0, x 0. Check here. 0, 0, x 0. Take the product. 0 into 0 is 0, 0 into x is 0, so 0. 0 into 0 is 0, again 0. X into 0 is 0, 0 into 0 is again 0. X into 0 is 0, 0 into 0 is also 0. So you get here A square equals to 0. So A power 16 will also be equal to what? Check here. A square power 8. Hence 0 power 8. Answer is what? 0 matrix only with the same order. So in this case, answer is option D. Option D. Have a look. So any integral power is given in the question usually gets solved easily by finding either A square or maximum A cube. That's more than which is required. You don't have to go beyond that. So this is your end of Masterstroke lecture in the chapter Matrices. Let me know how was the class and what do you feel about that. Do not forget to subscribe to our channel and join our WhatsApp community to get the access to the PDF of all the classes. And if you are preparing for KCET, this is the last time you can revise all the concepts in the best way possible. Okay, and of course for more question practice, don't worry, this is not the end of it. I'll bring more PYQs, more question practice in the live class as I brought for the previous two chapters. Okay, so we'll club matrices and determinant together and make one live, and you can solve those questions with me in the live class. Okay, so that's it for today's class. I'm gonna see you next time. Till then, take care. Bye bye.